Welcome today to JPSD's Applied Physics by Pioneering Women, a webinar. This is based on the forthcoming 2022 Applied Physics by Pioneering Women, a roadmap, which is to be published early next year. Today we're going to be offering a trailer of the roadmap. And we're excited today to start with a talk by Gillian Butcher entitled "The Space for Everyone." This will be then followed by a panel discussion moderated by Kirstin Alberi with Cathy, Foley, Youngah, Bonham Newman, and Leitao as panelists. Before we start, if I could briefly direct your attention to the link in the chat function, which will take you to the Slido for this webinar. Please post all your questions there. You can also vote for your favourite questions posted by others, and we will try and answer some of them over the course of the webinar. I'm now going to hand over to Cathy Foley, who will be chairing today's speaker section. Dr. Cathy Foley was the Chief Scientist for the Commonwealth Scientific and Industrial Research Organisation since August 2018. Since January 2021, she has been on leave to take up the role of Chief Scientist of Australia. Her specific research interests are focused on superconducting electronics, squids, skiffs, multiple Josephson junction devices, qubits, and quantum computing. She has won many awards too, including Women of the Year, awarded by New South Wales Government. And she is Editor-in-Chief for Superconductor Science Technology and one of the three lead authors on the aforementioned roadmap. So Cathy, over to you.
Thanks, Tom, and hello, everyone. Welcome to this webinar. It's very exciting. We've got people from all around the world joining us. But to kick it off, I'd like to introduce Julian Butcher, who is a space scientist and physicist, and she works at the University of Leicester in the Space Research Centre in the Department of Physics and Astronomy. Her first degree was in applied physics at Strathclyde University, and then went on to work at Thorn Lighting, designing and testing airfield lighting, and she studied for an MSc in architecture, looking at light and lighting at the University of College London. She then completed her PhD in physics at Essex University, using lasers to see how molecules line up in liquid flows. Her job at Leicester University now involves designing, building, and testing instruments that go into space. The instruments are all for scientific purposes, ranging from Earth observation studies to planetary studies to astronomy. Gillian is also the chair of the Working Group 5, which is all about women in physics, part of the International Union of Physics and Applied Physics. So Gillian, over to you.
Thank you, Cathy. Thank you very much for that introduction. I'm just going to share my screen. If I just make sure I share that. I am hoping that someone can tell me whether that's now sharing my screen.
That's all good. Yep.
Jolly good. Well, thank you very much, Cathy, and thank you for inviting me to participate in this exciting project. So in my talk, I'm going to give a little bit of background on my career, which Cathy's actually already gone through, and which has led me into the space industry. I'm then going to talk a little bit about the space industry itself and some of the pioneering women who have been and are a part of it, and some of the challenges they face. And some of these challenges will no doubt be shared with other areas of applied physics, and particularly I'm thinking of the large facilities of particle physics. So as Cathy said, my first degree is indeed in applied physics. I wasn't sure what it meant at the time, but I thought it sounded more practical and experimental than pure physics, and I certainly haven't regretted my choice. So, as Cathy said, I worked at Thorn Lighting, where I designed and tested airfield lighting fittings, followed by my PhD. So I then, ended up working in the Space Research Centre at the University of Leicester, designing and testing a detector for an Earth observation instrument on a satellite, this detector at the end. Subsequent projects have encompassed planetary missions, including the X-ray fluorescence spectrometer for the Beagle 2 lander on Mars, and more recently, micropore X-ray optics for planetary and astrophysics missions. I see the role as a bridge between the engineers building the rest of the instrument and also the scientists who use the data. But it's an interesting point that we sort of commonly refer to the astronomers or the geologists, those people using the data, as the scientists, while they in their turn refer to us as the spanner people. Now, it wasn't really a planned career choice to end up in space instrumentation. Growing up in a city conurbation on the west coast of Scotland, where the predominant weather feature is rain, I didn't really see much of the night sky or to feel enthused by astronomy or space. I thought space was about rockets and engineering, or about astronauts. So I was surprised to find that physicists did space. And then I discovered, in the words of the author Douglas Adams, that space is big, really big. Now, he was referring to the sort of geographical and the nature of space itself, but equally he could have been talking about the space industry. And so as I came to find that there are a whole series of different jobs that one can do in the space industry, whether it's a space instrumentation, whether it's satellites and spacecrafts, whether it's the launchers and the rockets, whether it's in propellant, a whole variety of jobs that you can do. And these could all be tasks that it could be civilian space or military, it could be industrial, or it could be in academia, and it could be upstream in the instrument building, or it could be downstream at the user's end, particularly the large field of Earth observation and remote sensing. And this is just a list that I took from the website last week from a space jobs website, which just shows some of the jobs that were available last week. And they range from, there's project managers and marketing managers, product assurance, and almost every type of engineer that you can think of. Although very few actually specify physicists directly, as we all know, we're a versatile bunch, so there are jobs there for physicists as well. So space is truly multidisciplinary, and there is a role for every kind of scientist and also non-scientists too. So the space industry itself really only began with the launch of the first satellite, Sputnik, in 1957. However, that is a culmination of many different strands of activity and projects. And when I was thinking about sort of women in space and historically, I've chosen to go back to Caroline Herschel. She became an astronomer in her own right, but started off assisting her brother, taking notes and helping make the telescope lenses. And this is a recurrent theme of not only women, but also of technicians and administrators and engineers working in the background, as Caroline is in this picture, to make the science happen. So likewise, this is a photo of the Harvard computers. Those women at Harvard University at the beginning of the 20th century who processed astronomical data, but who are also making their own discoveries as well within astronomy. Moving into the space age, we have a group of women who became known as the Mercury 13, who underwent astronaut training in parallel with the men in the 1960s. They outperformed the men in many tasks, but it was deemed against the social order for women to become astronauts, so they never made it into space. Other stories have emerged from the United States space program, including that of Mary Sherman Morgan, who's a chemist who developed the rocket fuel to launch the US's first satellite, and also the women featured in the fabulous film Hidden Figures. We have the engineer Mary Jackson, mathematician Katherine Johnson, and programmer Dorothy Vaughan. One of the things I particularly liked about this film was that while focusing on these individual women and their stories, it also somehow managed to convey just the numbers of people and the teamwork necessary for success of the mission. So the popular image of the lone science genius may make a good story and make for a good film, but it's not necessarily going to appeal to everyone. And it certainly isn't the case that that is how science is done in a lot of cases. Sort of moving on, so we're fortunate that people have chosen to write about such women to bring their stories to the wider public. And NASA itself is a rich resource of archive material. And from their website, they have information on their current women in their space programme. So this website showcases women in various roles. This part of the screen shows women in science or women in technology. There's also women in management and women in engineering. However, beyond NASA and the US, it does become harder to find the women in space. But I was particularly pleased to see this article about these 6 women from the Indian Space Research Organisation. And then also to find that Lisa Campbell, who's the first woman president to lead Canada's space agency, although her background is in political science. As I said, you don't have to be a scientist to become involved in space. However, as I was Googling material for this talk and looking up sort of women in space, it frequently took me to, it wanted to tell me about women astronauts, which is interesting in its own right. However, I was very impressed, it has to be said, when I found that in the Google search, that the top related search that came up for women astronauts was this pretty female astronauts, as if their achievements aren't enough. So thinking about some of the women who I know or personally know or know of, I was thinking of particularly Maggie Adderin-Pocock in the UK, who was a similar space instrumentation scientist as I am, but who's known for all her television work and does a great deal of work in outreach. Then I was very privileged to get to know Renee Horton from the US, a NASA engineer, who again does amazing work and does amazing outreach, and became president of the National Society of Black Physicists in the US. Elizabeth Seward graduated from Leicester before moving to Airbus in the UK, and has moved up the organisation. And she also set up the UK branch of Women in Aerospace. Then Corinne Mercier, she is the project manager for at CNES in France, and is project manager for the instrument I'm currently working on. And there are other women that I've known, but I've chosen to sort of highlight these ones. So one can find information online on Maggie and Elizabeth and Renee, because they have chosen paths that sort of make them visible, doing the outreach and working in organisations. However, Corinne is one of the many women and workers in the space industry working away in the background, building instruments, making science happen, and doing science. And at this point, I sort of raise the question of publications, which is problematic enough for women academics, but which is a real issue for people working in the space industry in academia. By the nature of our work, we publish very few journal papers, but do produce a vast number of reports, test plans, and conference talks. And our ultimate peer review is a working instrument that delivers data with which the scientists write their papers. So I wanted to make special mention of a team from Kyrgyzstan who are aiming to launch the first Kyrgyzstan satellite. They are a team of all women, teaching themselves the necessary skills to launch their satellite and teaching others, including travelling to remote regions of their country to do so. And I was fortunate to meet them when we sponsored them to come to an ESA symposium on space education held in Leicester a couple of years ago. They really are inspiring and pioneering young women. So you might be surprised to see just how many countries have space agencies. beyond the few dominant countries one might expect or know about. And my feeling is that, and to say my personal opinion is that the driver for at least some of these countries of a space industry is very much tied to political and military ambition. And while for some scientists that may be of no consequence, and they will be more than happy to take whatever opportunities to pursue their own science, for others that actually might be a real deterrent. However, there are many societal benefits of space, from the spin-offs directly relevant to society to those projects addressing all the problems of climate change. So there is much there for people who are interested beyond sort of political and military. Then finally, I'd just like to briefly highlight some recent reports that were published in the UK. I published on the results from the very first survey of the UK space sector. The most recent report focusing on women, and this is just a summary of some of the information. And it's interesting, this is just one graph showing the survey respondents and the subject that they'd chosen. And you can see that actually the majority in this case did have a physics background. But you can also see there's quite a variety of subject choices, and varies with gender. So this may focus only on the UK, but the reports highlight some of the challenges faced in the sector, and which will no doubt be relevant to the wider community as well. So there is space for everyone in space. And although I stumbled into it, it is too important a sector for women and physicists not to be a part of it. So thank you, and I shall now try and stop sharing my screen.
Thanks, Gillian. What a fantastic talk. I really enjoyed that. It's opened up a whole lot of things I didn't know about. To kick off, we've got a few minutes for questions, and I encourage people to use Slido and put any questions into the type a question, ask the speaker. So look, I do actually have something where you touched on it a bit, which is relating to women often don't have the same publication metrics, and so therefore when we're competing in a world where publication metrics seems to be the be all and end all, if we are going to change to have a broader set of metrics so that we would consider things that are important to being a successful researcher, what other characteristics beyond not counting numbers of papers and citations do you think we should be adding in when we're trying to have new design for metrics for researchers?
Thanks, Cathy. Yes, I think that's a sort of really important point. I believe in there have been sort of measures where people have tried to look at it's the question of how many people have you helped. So it's not just about what you yourself have done, but whether it's in your teaching, it's that sort of wider community that you've actually done, been able to spread and assist people, whether that's in teaching and they then go on to become successful scientists, or whether, in the case of people working in instrumentation, it's about we've built an instrument that lots of other people are getting the data from. That to me is sort of perhaps an interesting, not sure again just how you measure it, but that would be an interesting way to go. And it's very much that idea of passing on to the next generation as well. What your knowledge and experience. It's not just about putting it down in a paper.
Yeah, no, it's a very tricky area, because in some ways we've got the whole research sector set up where it's easy to count publications and citations, but one of the biggest issues is how to collect that sort of information in a way that's seen as objective and I guess able to be verified. So it is really tricky. I just remind everyone, I think I'm looking at the right thing with the Slido, and I haven't seen any questions come in yet. So I really encourage people, or if I've done something wrong, can someone jump in and let me know that I'm not looking at the right part of Slido? But look, I've actually got other questions if it's okay. And that is actually really interesting to look at how, if you think that women have been, very early on, being really instrumental in calculations and in really what is data science, I guess, mathematics, the human computers, I guess, that were done, highlighted in that wonderful movie. I agree, it was fantastic, Hidden Figures. Why is it then, when we look at the number of women in doing, say, digital computer science, AI, machine learning, that is actually really low? It's something like about 5% of in some places. Why is it that we've not seen women really take that on board? What's happened that it's flipped to being a male-dominated area when it was originally clearly female-dominated? Do you have any idea of what's happened, and any ideas that might be able to flip it back, or at least even it up?
Yes, I mean, I think computing science is a really interesting area as well, because when you think about some of the imbalances and the gender imbalances are historical, and you go back and you think how science was set up, and the physics and chemistry, and it was very male dominated. And then you think these newer sort of subjects, you'd think that you'd be starting off at a better, more level playing field. But as you say, the numbers in computer science are even worse. Whether there's something to do, again, perhaps whether it's just seen as being, because I think computer gaming perhaps has something to do with it. That's a sort of visible public side of it, and that to me always seems sort of very, very male dominated. It's very much the shooting people type of games that seem to be most popular. So whether there's something there, but yes, why, there are also some interesting, you think about even between pure and applied physics or pure and applied maths, there seem to be some areas which are just seem to be more dominated by men. And I'm sort of reminded of when I was doing some work with the Institute of Physics and the Royal Society of Chemistry, and there they were very much talking about that there were certain areas of chemistry and they could almost trace it back to certain groups. There was a sort of lineage of just groups having really good numbers of women, perhaps due to one sort of individual, one male who happened to employ a lot of women, and then that has sort of carried forward. So I'm sort of wondering whether that is actually the case as well, whether there just are areas where women just haven't really sort of thrived, or there hasn't been a sufficient sort of number to really get that I'm struggling to think of the word that I want to use, just that core number, which then sort of builds.
Yes, you get that critical mass too. Yeah, they say it's about 30% for things to just be normal, to be felt like. As soon as you get over that 30% point, then it's like it's not seen as sort of a minority group. Look, we've only got a minute or so left. I think I just want to just finish off with one question, if you can answer it really briefly. And that's actually, we often talk about women in science and things like that, but I'm just, your science is amazing. The ability to make a device that can go up into space is extraordinary. And I'm just wondering why, just from your perspective, what's the most difficult thing from a researcher to be able to make, take your science and put it into an application? What's the one thing that's most difficult to see that through? Because it's not easy. As someone who's a device person too, I wouldn't dream of putting something into space. So it's extraordinary what you've achieved. So are you able to just, we've just very, very briefly just consider what that might be?
I think it's all about finding the right teams and the right people. You need the scientists need to be talking to the people who are doing the materials, who are doing the new instrumentation. You need to be talking, finding out what are the issues, what are the questions that they want solved. Is your science going to be able to do that? And it's then just being able to find and build up a team that you're then going to be able to build an instrument. And then there's all business about getting it funded. A lot of these missions are obviously sort of quite large, and to get them funded. But I say it really is about teamwork. You cannot do it yourself in a lab.
Well, thank you. We've run out of time, but it's been really fantastic presentation, and thank you so much. And I'm going to go back to Tom, who's going to take us to the next stage. So thanks, Gillian, and it was a fabulous talk.
Yes, thank you. What a fantastic talk. It really set into context the next part of the discussion, and which will be the panel discussion. But before we get to that, I just wanted to have a brief interlude highlighting one of the reasons we decided to hold this webinar today, which is this roadmap that which we're in the process of publishing. So this is roadmaps are a program of articles that we've been publishing in JVSD, covering a wide range of topics. These multi-author pieces covering the whole field, spanning whole fields, in fact. This particular roadmap is written by women scientists only and edited by women scientists, and is a broad multi-author piece covering most topics in applied physics, and highlights work, highlighting work by pioneering women in their fields. In particular, we focused on areas where women are pioneering new breakthroughs, and provide suggestions on how the research community can foster greater engagement and leadership from women scientists. So a very exciting roadmap, and certainly one we're looking forward to publishing, and I hope one that that you will look forward to reading. So if you want other roadmaps, if you want to read other roadmaps on a wide range of topics such as UV emitters, plasma technology, and materials by design, please go to this link below, and there you can read them all for free. Okay, on to the next part then, which is the panel discussion. Today's discussion will be moderated by Kirstin Alberi. Kirstin is a researcher at the National Renewable Energy Laboratory, and her research interests include optical and electronic properties of semiconductor alloys for photovoltaic, solid-state lighting, and other energy-relevant technologies. She's also a board member for JFISD and a lead author on this roadmap. She'll be joined by panelists Cathy Foley, Youngah, Bonham Newman, and then Diana Leitao. Since Cathy's already been introduced, I'm just going to introduce the other panelists. Youngah has been a professor at the Department of Physics at Myongji University since 1989. Dr. Park served as president of Korea Institute of S&T Evaluation and Planning from 2013 to 2016. Her research areas include critical phenomena, neural networks, soft matter, and biological physics. She's also a lead author on the roadmap. Diana Leitao is a lecturer at Eindoven University of Technology, having recently moved from the Instituto Superior Técnico in Portugal. Her works focus on nanofabrication of magneto-resistive devices. She's a JFISD board member and an author on this roadmap. And finally, Bonham Newman is a researcher at TNO Solar Energy in the Netherlands and an author on the roadmap. Her research interests include circular PV cell and modular design for maximum performance and integration of photovoltaic technology in new applications like vehicles. So now we're going to hand over to Kirstin, and thank you very much. Kirstin.
Thanks, Tom. I'm delighted today to moderate this panel where we'll discuss the Applied Physics by Pioneering Women roadmap, as well as the topics of women's involvement in applied physics more generally. I'd like to remind listeners to please do submit questions via the Slido link in the chat, And in the meantime, I will kick things off with a few questions to set the stage. So Cathy, I'll start with you. You are one of the lead authors of the roadmap. So what was the motivation for putting this document together that highlights women's contributions to applied physics?
Yeah, look, it's a really good kickoff question, because in the process of pulling this together, I actually dipped into the literature a bit to see why, to give some evidence as to why this is a good idea. And I found some really interesting research that showed that, and reinforced my gut feeling, that when we actually highlight women's achievements, they're actually taken more seriously. And I think it reinforces the importance of things like awards, special issues, important talks, highlighting the results that women have achieved. Quite often, I think women tend to feel like, I've done this, it's been a team job, and I'll just go on and move on to my next thing. Quite often, we don't step back, take a breath, look at what we've achieved and celebrate this. So my feeling is that this is such a fantastic initiative. I've never seen something done in the physics area before where they've actually looked at a special issue where all the work has been authored by women. And as a consequence, what we're seeing is some really fantastic work, which is showing the excellent research that women are engaged with, which is world leading, changing the way we think about different subjects, and also creating a feeling of, I think, also connection amongst women researchers too, to create a sort of a whole new applied physics network.
That's a great way to start off this panel discussion. Youngah, I'll go over to you now. You are another lead author on this roadmap. Could you walk us through some of the editorial considerations that went into its design, especially regarding considerations around selecting authors and topics?
Yeah, thank you, Kirstin. It's a good question. So as we have been talking about, so in this roadmap, we wanted to include all the aspects of applied physics by women scientists only, highlighting women in applied physics doing breakthrough research. So in the roadmap, we had some editorial key points for the authors. First, the authors will work together to produce a single document, so they communicate with their colleagues and with respective co-authors, and how to divide up the work and who is responsible for the work. So this is a very collaborative work. And secondly, in the spirit of diversity and inclusion, we have tried to be as diverse as possible with the author selection. So we have the widely selection of point of view. So if a section only has 2 authors, we encourage them to invite a third co-author especially from non-Western or Global South Institute. And thirdly, when we write in the piece, we ask the authors to focus on women scientists' contribution for their respective topics, as well as to provide any comment authors would like to on ways in which their field have done a good job or could do better in creating an inclusive environment for women. So we ensured that authors include work by female colleagues also. Some authors forgot to do at first. So in terms of a career stage for the authors, we highlight the women who have made a significant breakthrough contribution to each field in the past, and those who are leading the charge or are the rising stars for future advances. So we have a good combination of senior women scientists and young researchers. So in each article, we have a young, promising scientist as a co-author, so that we featured each one of them together with the prominent women scientists. Also, the editors tried diversity and inclusion in terms of each research field and countries of their authors. So we try to enlist all the important fields of applied physics as much as possible. So finally, we could have 15 subsections with an introduction from 43 authors. So the article includes plasma material processing, plasma propulsion, super resolution microscopy and microelectronics, spintronics, nanomagnetism, and skid technology, quantum materials, and 2D materials, catalysis and surface science, multivalent batteries, fuel cells, photovoltaics, and neuromorphic computing and device, and finally, neuromorphics and nanoformics. So we achieved enough diversity in research fields and wide selection of point of view. So in terms of diversity, in the region and the countries of all the authors, we have 9 authors from US and 15 authors from Europe, including UK, France, Germany, Netherlands, Switzerland, Italy, Portugal, and Romania. And also 2 authors from South America, and 5 authors from Australia, and 12 authors from Asia, including Japan, China, India, Korea, and Middle East. So totaling 43, which include all 6 continents except Africa. So by ensuring diversity in region and countries, we achieve diversity across race, ethnicity, and nationality. So that's all I will say now. Thank you.
Youngah, thanks for that detailed overview of the contents of the roadmap itself and how it was put together. Let's dig into a bit about the actual content of the roadmap. Bonna, you co-authored the section on photovoltaics. Can you give us 1 or 2 examples of outstanding contributions that you and your co-authors highlighted within the field?
Yeah, thanks, Chris. So there's actually a lot to choose from in the field of photovoltaics. There's women that have really been contributing in photovoltaics since the early years, 30 or 40 years ago. In fact, many of those women are still involved in the field today, which is really great to see. I think, though, if I have to highlight one today, I would focus actually on Ulrike Jahn, who actually just this year won the Becquerel Prize, which is one of the most prestigious prizes in the field of photovoltaics. And part of the reason I do that, even though she's won a big prize recently, is that there's actually only 2 women, despite all the activity of women, there's actually only 2 women that have ever won the Becquerel Prize. And so she also represents quite well the way that photovoltaics is actually a multidisciplinary field, and that it's not just about the technology, but also about the customers and the people that will use the technology, because that's really everybody. So she was an early pioneer in working in trying to get solar adopted and well used, and demonstrating to people on their residential homes that they could actually have solar installed, that it would be reliable and a useful investment. And she was part of the 1,000 Roof program in the 1990s. And then she moved to the TÜV Institute in Rhineland. And there she really ended up leading part of that group there that really helped to establish the trust from the market side about the reliability and the performance of these panels and modules. And the way she did that is through the development of a really excellent testing program to do accelerated lifetime testing and prove that these sorts of photovoltaic could actually be used for 20, 30 years in the field, and create the trust that's necessary between the technologists and the market in order for technology to be applied and be adopted. Now she's actually the IEA PVPS Test 13 leader as well, and really excelled on the international stage by bringing scientists together from all over the world to work on reliability and performance issues for photovoltaics.
That's a really impressive example. And I'm sure, like you said, that there are many more that you could have highlighted in that space as well. Diana, let's get some input from another field. Having gone through this exercise for surveying contributions of women to the nanomagnetism field, what's your impression about the representation of women today? And do you have any thoughts on the trajectory into the future?
Hi, first, thank you for the questions and also for being here. Yeah, being on the inside, it was, I would say personally, I feel that we are still underrepresented, especially in my field, but the number of groundbreaking achievements are very high and very good. So putting this piece together in that sense can work as an eye-opener. So, and the sad part is that we have to leave several people out because there is not enough space. So that is something that maybe you also felt through. But in the end, it was clear that the merit and the achievements are there, and we need to highlight them. And although we are, as a group, still very much underrepresented in my field, I would like to highlight that there are several initiatives that try to support and bring us together. And I think these initiatives are really, really important. I have connected to some of them. I have get to know my role models in several of them. And I think these are really, really important networks to boost our career, to boost our confidence, and really to have an impact and to show the impact of our work, as Cathy just highlighted.
Yeah, that's great. I mean, I did also find that as an author, having enough space to really highlight everyone's contributions was certainly difficult there. This question is for the entire panel. What is the insight or surprising piece of information that you took away from working on the roadmap? Cathy, I'll start with you. Cathy, I think you're muted.
For me, the main thing was that everyone had more than enough women to put in, as you've said. It's not like there's a shortage of women involved in applied physics. And quite often, you know, when we're organising conferences, people always are saying it's so hard to find women to be plenary speakers or invited speakers. And I think that we've now got a resource that they can go to, and there's no excuse, there's plenty of them. So I think that's one. And then the second is probably that the importance of having that diversity in all aspects. So as Youngah pointed out, both cultural, age, and different discipline areas shows the richness of, you know, bringing together all these different aspects is where you get good outcomes. And I think that was something which really was reinforced by this exercise.
Great. Yeah. Youngah, maybe you can weigh in here as well.
Yes. So I completely agree with Cathy that I didn't expect that so a lot of prominent women scientists can prepare all the applied physics. So I'm just joking. We may not need men scientists. So I'm just joking. So by pursuing the roadmap during the almost last 1 year, I found that it is surprising to find out women physicists did contribute tremendously in applied physics, enlarging the boundaries in their respective field. So in some article, the list of women physicists who have achieved and pioneered in the fields is overwhelming, even starting from the abstract. So it was so nice to see the photos of accomplished women physicists in the article itself. So also, by the process of co-authoring with senior scientists, young researchers had a chance to closely communicate with them and mentoring from the senior scientists. So I'm sure that it is a very inspiratory experience for young researchers, giving them an insight and challenge and courage for the future, for their future. So that's all I will say now.
Yeah. Bonna, over to you.
Thanks, Kirstin. I think, in addition, of course, to what Cathy and Youngah have said, one of the most surprising aspects for me in doing this was in listing all the women that have been involved. There's so many women that have also been involved, not just in the physics part of things, but in the applied part of things. As Julian pointed out in her talk, there's room for expertises and talents and skills, not just in the technical side of the physics, but also in the other aspects of reaching out to the community, making sure that there's good team building, that there's, you know, good project management, etc. That all of that really plays a huge role in really making physics applied and useful for everybody, for people's lives. And so, yeah, and we see that quite a bit in the world of photovoltaics. In fact, many times you see women with very strong science backgrounds that have really made their mark actually not in the technology side intensely, but really in making sure that that technology side can really be applied.
Mm-hmm. Yeah. And Diana, what are your thoughts here?
Yeah, I would subscribe everything that it was said, of course, but I find something also very interesting. That is, these pieces were written independently, so we talked to the group of our field. But then when you go through it, you actually see people that that go over different fields within the applied physics world. So you see the same names or similar names popping up, and this is very interesting because I think it really shows how big is the impact of the work of these colleagues. And this is, for me, it was really striking because since we didn't talk before, you really see that these people are really making a strong impact in different fields, although in physics, of course, in applied physics, but nevertheless, I think it's a very good piece to highlight achievement.
Yeah, you're right that digging into the background of what physics or women are doing here in physics is definitely eye-opening when you actually spend some time to see everyone's contributions. Let's take a question from Slido. If you could give one piece of advice to women early career researchers or students, what would that be? And Diana, maybe we'll start with you this time.
Okay, so I would for sure, the first thing I always say is go for it. If you have a heart for it, just go for it. Don't let anything get in your way. Then seek mentorship. I think mentorship is really can be really supportive in all stages of life, and a personal piece of advice, or something that I tell myself at least, is be involved in outreach activities. And this goes very in line with something that Cathy says. I really think there needs to be diversity in, for example, conference committees. I think we need to have a voice, and we need to be there to have that voice and give our suggestions. Just make sure that we are leveling the playing for everyone. So contribute as you can to the field where you are, as much as you can and as much as you are able to. That is a very personal view.
Thank you for that. Bonna, we'll go to you next.
Great, thanks. I guess there's two pieces that I would suggest. One is building a network, which includes a mentor, but also people that are your colleagues that you think can help support you. And that can include other women that are in your field, reaching out to them, making a special effort, but also the men and the other people around, your other types of colleagues, because they can also help, they'll help connect you to things and you know, open up opportunities and offer, you know, lots of good opportunities for doing new types of research, etc. The other thing I would emphasize is communication skills. I think in science, this is in general, of course, this isn't just for women, but your communication skills, especially these days with social media and 24-hour news cycles, etc., it's really important to make sure you know how to talk about the research that you're doing and make sure people understand the impact of it. And so focusing on that from a really, not just being able to write a paper necessarily, but focusing on that from an early stage of your research career can really help in terms of maximizing impact and the overall experience that you might have in your career altogether.
Mm-hmm. Exactly. Youngah, could you give us some advice here as well?
Yeah, first of all, find a field which you would like to make a challenge and go for it and do your best. I'm sure that you may meet some challenges and obstacles, and especially the prejudices, but never be disappointed. And keep forward until you reach your goal and develop your own superb scientific specialty. I'm sure that you will be rewarded. So also, these days, scientific research cannot be done alone. So collaboration is essential in many research areas. So it is important to find colleagues to work with, to collaborate with, and learn how to communicate with. So you needed to develop communication skills, as Bonna told us. And also, overall, so in the scientific research itself, so networking is important, especially for the women scientists. So try to be social in scientific way. So thank you.
Thank you, Youngah. And Cathy, we'll end on this question with you.
Yeah, look, I was going to talk about networking, but that's been covered. But the aspect of it is one way that really helped my career was engagement with conferences and using them to really build your career. If I go through looking at my career pathway, engagement in conferences allowed me to meet collaborators, people who might be my referees in the future, people who might be giving me a job in the future. So that I think of conferences not as somewhere where you just turn up to present a paper, but also a place for you to build your career and do a bit more planning with that. Another one personally is I'm in my 60s now, and so you've got to remember to play the long game. You're going to be in. If you really love research and physics, applied physics, you're going to be there for a long time, decades. I've been, 40 years working as a physicist in different, mostly in CSIRO, but at university and now for the government. And I, at that time I had children. I've got 3 of my own and 3 stepchildren, so I've had a life, and you can actually, play the long game. Know that you don't have to do it all at once. Just know that you're gonna have highs and lows. Everyone does. And don't feel like you're falling behind. Just look at your own situation. And then I guess 2 other things is learn to give a good talk. I think communication, Bonna was saying the importance of communication, but I would, if I was going to specify one aspect of it, is learn to give a good talk. And if you're not so sure about it, because I know people often think that if you go through asking what is your greatest fear, giving a talk often trumps dying. So I think a lot of people are afraid to give talks. I was probably one of those people, but the more you do it, the better you get. And these days, there's so many opportunities to learn, just going onto the internet and studying and having that self-development, which you can do by just looking at like TED Talks or studying books about it. You can really develop and get to that point where you can learn. And giving presentations is important, not just at conferences, but pitching your ideas. And if I've got time for one other thing, which really makes a big difference, and this is a little bit funny, is learn to where to sit in a meeting so that you get heard, because often women don't get heard in meetings. And this has been something that has been really important for me. And that is always, if you really want to be heard, sit opposite the chair. Don't sit next to them. Don't sit at the end of the table. Sit right opposite them. So get into the meeting early so you can bag the best spot, because you will get heard, because women often don't get heard in meetings, and so that really helps.
What great advice. Yeah. Let's go to another Slido question. Do you think the fact that women have been overlooked for a long time is related to the fact that women might have a harder time to network? And I know you guys have touched on this a little bit, but I'll open it up to the floor here if anyone has any thoughts in addition to what's already been said there.
Well, without hogging this scene, this is something I've given a lot of thought about, is why is it? I've been involved with women in physics for 40 years, and it's still not where it should be. Look, we live in a very gendered society. The moment you're born, what's the first thing people ask? Is it a boy or a girl? When we look at just the whole thing of gender at the moment, like LGBTIQ+, all that sort of thing, makes a lot of people uncomfortable. And the reason for that is we tend to define our roles and the way we engage with people based on gender. And that goes through with the whole way our society's set up. And this doesn't matter, sort of doesn't matter where it is around the world. I think there's been some great surveys done of physicists undertaken by the American Institute of Physics that shows it doesn't matter whether in high or low GDP countries, that it's pretty similar. And And so that whole thing of women being positioned in a certain way, being looked at in a certain way, has carried on. And even the way we do science and do research is very gendered. And I think as a consequence, the fact that women are the ones that bear children, that we have only now got to a point where parental leave is there. In some countries, there is no parental leave. In some countries, we found at the International Women in Physics conference held in July that there's some countries where women don't even have toilets in their physics department still. And so, those sorts of basic things are just still being a struggle, even in countries which are high GDP. And we still have a long way to go across, the world to be able to realize that the way the world is being structured is being very much designed for the male way of thinking, and bringing women in has taken some time because we've got to break things down and rebuild them. That's my little sermon on it, but others might have other views.
Right. Any other thoughts here from other panelists?
I have been kind of involved in this women in physics activities during the 20th century, 20 years, not 20th century, and from 2002. As all of you know, that this IUPEP, Working Group on Women in Physics, started a few years before that, and there was the first women conference, IUPEP, Women in Physics conference in Paris. So after that, I myself involved in establishing working group in Korean Physical Society, and also working group in AAPPS, the Association of Asia Pacific Physical Societies. So the kind of environment and atmosphere has been changed a lot during the last 20 years. And there was a little bit of improvement of women participation, because I remember that at the time, about 10% of this KPS member was women. Now it is becoming 20%, but not 30%. So there is some hope and some kind of disappointment. But as a whole, things will improve. That's my kind of positive point of view. But we need some thought and some kind of improvement, like some institutional way. So I'm not sure, but I see some hope also, because especially as I involved in this roadmap of applied physics, pioneering women in applied physics, I am quite surprised that there has been so lot of improvement and so engagement of women physicists in all fields of physics and in all fields of science. So I just want to keep hope. That's all I want to say now.
Yeah, it's great to see that trajectory. We'll just end here on one more question from Slido. What is the support that you wish you'd had at the beginning of your career? And Bonna, I'll start with you.
Yeah, actually, with response to the last question, I guess also directed towards this question, it's a great question. I actually found that I had really good support in the very beginning of, at least during my PhD, because I was at MIT, and less than 5% of the graduate group at MIT was women. Because of that, we put together a women in physics group, and actually were able to go to the department to ask for funding for that. And the funding basically just paid for us to get together every couple of weeks and have dinner, which, maybe the funding, there's a question mark, I guess, of exactly where that funding comes from. But what it did was it allowed us in a really large physics department that we knew all the women in all the different fields of physics, which is something that our male counterparts actually didn't have the advantage of. And so by knowing all the other women in the physics department that were working in astrophysics and atomic physics and, theoretical physics, we were able to make connections and make things happen, and actually speak also to the administration in a way about what they could do to help us out. They gave us a much stronger voice. So I guess that's you can find support in really different ways. And oftentimes your other female colleagues can be a big chunk of that support. So get involved with those networks, because they can be very powerful.
What great advice. Diana.
Yeah. Okay, so I feel a little bit in the same way as Bonna, because I also feel those networks are really powerful. So it's a great way to feel supported. What support would I wish to have had in the beginning of my career? I was strongly supported during my PhD, but indeed the impact of networking later on in the career is, I would say in my case, was a little bit overlooked. So I would say that the advices that came up here today on the importance of networking, appearing, being present, know how to present, are some of those I really wish I would have very early on in my career. So it's good that they are coming up here.
Yes, absolutely. Youngah, what is a piece of support that you would have wished for?
Well, I mean, my case is a little bit different from the case of Bonna. Yeah, in my undergraduate, I was the only woman, female student in my class, and all the senior levels have only one or two this female student. So, and at the time, the Seoul National University, though it was the best in Korea, it was quite unsupportive to this female student. So the good thing is that I was kind of forward, going. I was in the type of going just forward. So I was not that much disappointed and not discouraged. And the good thing was that my classmates themselves, the older male, were quite supportive to me. So I made friends with them during the undergraduate. But the disappointing point of view is that I came back from USA after finishing my degree, and the teacher, my undergraduate professors, quite embarrassed about that, about the fact that there will be a lot of difficulty for me to find a job. And at the time, about 40 years ago, it was so much difficult for me to find a job at university, because in those days, the professors didn't look the application from the woman PhD. So anyway, I got a job. So, and as time went on, now I see that my younger generations are going forward and find a good job and good opportunities. So I am happy for that, and it was my kind of experience and happiness for me to give some help for my younger generation. So we had, I think, in my age, like Cathy, had some difficulties, but now the younger generation of the Foleys had a much better experience and opportunities. So I'm happy for that.
Yeah, thanks for that perspective. And Cathy, we'll end it here with you.
Oh, just very briefly, I think if we'd had a women in physics thing when I was doing my PhD, it would have been me in a room on my own. So it's good to see things have come a long way. I think the one thing is I wish that someone had given me more support on how to look for a job and look more broadly, realizing that you can use physics, especially applied physics, in a whole range of areas, not just in research academia, and also not to panic. I think I used to worry that if I was coming to the end of a contract, because we know that early career research is often got lots of short contracts, and the work is quite unstable, is that to have belief in myself and having that idea that I will get a job, that I'm good at what I do, and that I shouldn't panic and think I'll go and get a job doing something completely different out of the field, and I guess trust myself and my skills better, and have people telling me that.
What a great piece of advice for any stage in your career, actually. Thank you so much for the panelists for your insight and willingness to share, and also thank you for everyone who posted questions in the Slido. And with that, I'll send it back to Tom.
Thank you very much. Thank you so much for this excellent discussion today. It's been fantastic listening to this. Some really interesting points made and some very useful advice given, I hope. Just to end, the roadmap will be published sometime in 2022, and we'll obviously be making a big announcement about it when we do publish it. Thank you everybody today thank you to Gillian for giving an excellent talk, and thank you to Kirstin for moderating the discussion, Cathy for chairing the talk, and Youngah, Bonna and Dana for participating today, and also for being authors on the roadmap. I'm just going to I think this is the end of the discussion now, so thank you very much, and also thank you to the attendees for coming along and asking lots of questions on Slido. So I'll just say goodbye now, and I think that's the end of the discussion. Thank you very much.
Bye. Bye-bye.